Hello everyone. In this video, I am going to show you my way of designing this type of shaft with a small gear on it. I will start from an empty assembly, and I will design a spur gear here. You can find the spur gear on the Design tab, under Power Transmission. Click on the spur gear icon, and you will get a notification that the assembly must be saved. I will save it in a new folder. When you are creating your projects, you should change the suggested file's default name to something more descriptive. But for this purpose, I will leave it as Assembly1. After saving the assembly, the spur gear component generator window appears. Here, I will change some values for my gears. I will use the center distance option. It is set to 80 mm. I will use that. For the number of teeth, I will use 23 teeth for the small gear and 57 teeth for the large gear. The face width of the gear will be 20 mm. Let me check the data here. I want to check the diameters. For the small gear, the pitch diameter is 46. And this is also important, DF is 41, which is the diameter at the bottom of the teeth. Okay, I can try to run the calculation for this setup. As you can see, nothing is marked in red. The message reads, "Calculation indicators design complies." This gear part will pass the load conditions. The applied load is 1 kilowatt on the input. I will click OK and wait for the gears to be generated. Here is my spur gear. The exact position of the spur gear is not important. The thing that is important is that the small gear has its origin in the center of its cylinder, and that the Z-axis is the cylinder's main axis. That is the key requirement. All other positions are not important. I will close this, and save it. Now the spur gear is saved. Now, I'm going to select Assembly from the New drop-down list to create a new assembly, where I will design the shaft. The shaft is also located on the Design tab, under Power Transmission. Again, the assembly must be saved. I will leave its name as Assembly3. The shaft and the shaft component generator window are displayed. The first segment of the shaft is a cylinder with a diameter of 30 mm and a length of 40 mm. I will leave it as it is. The next segment is a polygon with 4 sides, but I will change it to a cylinder. I will change the diameter to 35 mm. And the length will be 15 mm for now. The next one is the middle segment. It is also a cylinder. I will adjust its diameter to be 40.5 mm, which is slightly smaller than the root diameter of our small gear. The length of this segment will be the same as the face width of the small gear, which is 20 mm. Click OK to close this dialog box. The next segment will be the same as the second one, which means 35 mm in diameter and 15 mm in length. Now I will add another segment, by clicking on Insert Segment command. Its diameter will be 30 mm. A bit smaller than the previous one. But the length will be the same, 15 mm. This column here contains features for faces on the right side of the cylinder. I may want to add a chamfer here. I need to open a drop-down list and select chamfer. I will apply a chamfer of 0.5 mm at 45 degrees. In this column are features for faces on the left side of the cylinders. I will add a fillet. A radius of 2 mm seems too large, so I will change it to 0.8 mm. On this cylinder, I will also apply a fillet of 0.8 mm on the left side. For the middle segment, I will not change anything. On this segment, I will also add a fillet of 0.8 mm, but on the right side. His cylinder already has the standard shape for grinding. Now I will click OK. Here is my shaft. I will save it. And here click OK. And the shaft is saved. Now I have two assemblies. One contains the shaft, and the other contains the driving and driven gears. Next, I will create a new part. And in this part, I will use the derive command to place my shaft inside it. I will use only solid bodies. And here it is my solid. Click OK. And here. Now I will use the derive command again to insert the small gear. This one, Spur Gear 11. Click Open. I will select the solid body. Click OK to close the dialog box. What is going on here? The spur gear and the shaft are placed with the same UCS orientation. Let me open the base component for the shaft. Here is the origin. Click on Origin Point. The origin starts here. Click on the Z-axis. You see, it points in this direction. This means that the spur gear is aligned Z to Z, Y to Y, and X to X with the shaft. So, I need to move the gear, here, to the correct position on the shaft. First, I will measure the distance to know the exact position where the gear should be placed. The distance between this face, and this one. And it is 55 mm, as shown in measure. In Modify, there is a command, Move Bodies. I will select the gear's body. As you can see here, I have options to move it, or rotate it. I want to rotate it by 90 degrees. And here I need to select the rotation axis. I will select the Y-axis. Next, I will move it by 5.5. In this template, the units are in centimeters, so 5.5 centimeters equals 55 millimeters, which we measured previously. So, I can enter 55 and adding millimeters for units. I will confirm with OK. And here it is. We have the shaft with the spur gear placed on it. Now, I want to combine these two bodies into a single body. You can see that this is currently a multi-body part, as indicated with this icon. To combine them, I will use the Combine command. The base body is the shaft, and the second body is the gear. I will combine them with Join. And confirm with OK. So, what is the purpose of this design approach? First of all, you are using components that you can calculate. Inventor's calculator is very reliable. From the gear calculation, you can obtain the forces acting on the shaft. Then, you can run the calculation for the shaft and determine the forces acting on the bearings. After that, you can calculate the bearings themselves. Another advantage is how easily you can modify the geometry. Here you can see that this fillet radius is too large. It should be 0.8 millimeters, but it is larger. How do we change it? I know the part is here. And I can open the base component. If you open that, you can change it directly from here. But I do not recommend it. Instead, we find the assembly where the shaft was generated. Here it is. And now, when you right-click on the shaft, the Edit Using Design Accelerator option is available. Here, we find the right fillet. Instead of 2 millimeters, we change it to 0.8 millimeters. And confirm to close. Now, when we return to the part, we see that an update is required. Here is also the icon showing that update is required. After updating, the geometry is corrected. You can also connect parameters between the gear and the shaft using iLogic, a add-in, or another automation method. For example, if you change the face width of the gear, the middle shaft segment, this one should automatically update to match it. However, here we encounter a limitation. The main sketch is not editable. This means I cannot take these measures from here. And when we check the parameters table in assembly, we see it is also empty. There are no accessible parameters. Because of this limitation, I created a post on the Inventor forum several years ago. Unfortunately, it has very few votes. It would be great if you would support it. The idea is to make user parameters available for use from the design. As you can see, I cannot use anything from this shaft. Also, I would like to use parameters from the calculation. For example, when I calculate forces on the supports, I want to reuse those forces directly for bearing calculations, without manually copying values. Now, the process requires me to open this, and place the force from my gear calculation. That means I have to first open the gear calculation, copy the value or write it down in the notebook. And after that open the shaft calculator and change this dimension. I do not like this workflow, and that is why I suggested this idea. The link will be in the video description. Please support this idea, it would be very useful for the entire community. So, this is my approach for creating a very simple shaft with a spur gear. From here, you can do much more. You can use all options available in the design and power transmission panel on this shaft. You can use and create involute splines, and parallel splines. You can place key on your shaft, and everything is in few clicks, because everything is supported with the database. And that prevents you from making mistake what key you should use, what is the dimension, what is the depth, and other things. I hope you liked this video. Please subscribe, like, share this video, and support my idea on the Inventor blog.